Hello, it's Sparky here. I had somebody email me already and wanted to know how to wire up this time clock and contactor from that last video that I did of kind of miscellaneous stuff. So I'll show you a couple things here, and I actually have a wiring diagram, and I'll post that on the website so that you could download it if you want to and keep it with you. But basically, this is a time clock, 110 volt time clock, and it controls this contactor that has 4 circuits to it going out to different lighting loads. So this one has a 120 volt coil, and we've got 120 volts coming in to the time clock. And in the wiring diagram, I'll show you this a little bit better, but you land a neutral here for the time clock itself. The motor that's up here is 110 volt, so you need the neutral for that, and then your line power in, and then you have load power going out. In this case, the load is going to be the contactor, not the lights, not the light fixtures, not the branch circuits or anything else. The actual load is this contactor. So just briefly again, you've got your line power coming in from your panel or whatever. You got your neutral, don't forget your ground, and then the load will go to that contactor. Now here's a time clock that doesn't have the plastic insert on it. I just want to show you up close a little bit. So there's your neutral there, there's your line, and there's your load. These have a manual on off to them. They've got trippers. This one's missing the off tripper, but this one's got the on. So as the time goes around, it'll turn it on and off. That's how they operate. You can look over here on your time clocks nomenclature. Will tell you the amperage and voltage and other things that you need to know. It's even got a little wiring diagram on the inside of it. Kind of shows you what's going on. Here's contactor. This particular one's only a 2-pole contactor. So the key thing on this one is your coil. So back here it shows you that it's a 120 volt coil, and here you'll use stake-ons, or you can wire directly to the terminal screws. Stake-ons is a whole nother video. I'm gonna try and get that done this weekend too. It's Memorial Day weekend. I hope everybody's having fun. 2011. I'm making videos. That's what I have fun doing. Anyway, hook your load from the time clock to one side and tie your neutral, whether it be the stake-on or the terminal, to the other side, and that operates your coil. And then you'll have your line side coming in from your panel for your individual branch circuits. And it's just another top view here. Kind of gives you a little bit of the information for the coil. And then a front view. So you've got your line, and in my one line diagram you're going to see this a little bit better. You have your line. You could have 110 there and 110 there, controlling different lighting circuits. And then you have your load coming out. Now you can use the stake-ons on these as well. Same up top here. Let me go back one picture. You could use stake-on, so if you're using stranded wire, you can either go underneath that plate, or you can go ahead and just kind of stab them on there. So let me go back here. And so that's really all there is to a contactor. There's not a whole lot to it. But I'll show you this next picture here. And it gives you a 30 amp full load amperage rating. Tells you the number of poles, what horsepower, locked rotor amps, voltages. This one's good up to 600 volts. So there's all sorts of information on the sides of these. Alright, let's take a look at this wiring diagram here, and I'll explain a couple things to you first and then go back over the purpose of everything. You have line power coming in, probably a 15-20 amp circuit, depending on your house or commercial building. 20 amp circuit. You have a neutral, and you have your load. So in the photos that I showed you earlier, your neutral go there, line power coming from the let's say a panel, and then your load being the contactor. And then up on top, the two terminals that I showed you, one of them will be a hot, the other one will be the neutral. That's the dashed line, there's the neutral. And then going down to here, let's say this is your panel. You've got breaker A and breaker B, circuit 1, circuit 2. And it goes up to the line side. So this would be the line, this would be the load. So when that time clock goes around to the on time, and it'll trip that, you saw the mechanism, manual or automatic, that'll trip that and connect these, the line and the load. It'll close that circuit, and then it'll send power to the coil itself. These will be continually hot, and then when the time clock sends the power over to the contactor, that coil will suck that contactor in and close these two circuits, sending power out to your light fixtures. So that's really pretty simple as far as a line and load situation. This particular one, the time clock and the pitchers, time clock contactor and the pitchers were 4 circuits, and they actually had a separate breaker feeding that time clock. And the purpose of that is if for some reason circuit 1 trips, then at least circuit 2 will still be working. You'd still have some outside lights or inside lights or whatever you're operating off of this. So this is a very, very simplistic form of this particular thing. And what I was talking about earlier is sometimes people interlock the time clock with a photocell. So the photocell could override the time clock or vice versa. And in another video, I'll draw up the one line for that for you. So if you've got any questions, post them down below or shoot me an email, whatever you want to do. And let's go back. I want to show you another contactor. It's a little bit different than the first one I showed you. So let's take a look at that. This is the other the contactor that I was showing you, and it is one of the simplest forms of contactors that you can get, the simplest type. You have your coil, you have your line and your load, and really that's all there is to it. Now in this next picture here, let's flip through this twice. I'm going to get into another contactor. Yes, this is an old one. It's still a 120 volt coil, but here's your terminals for the coil back here, and that's what your time clock would be operating. And in the next photo here, this is actually a three pole, so you could have three different phases. This could be a motor, could be for lighting, could be just about anything, but it has these other contacts on here, normally open, normally closed. It could do various different things. So if you had lights on during the day, you could hook that up to your normally closed, and then if you had let's say your lighting came on at on your patio, was needed to come on at 7 o'clock at night, and you had lights on in your store, when that time clock came on at 7 o'clock, it would actually cut the power to the lights in the store and provide power to lights outside the store. So it's kind of a dual function transformer. Or you could use it for other control work. Let's say it was hooked up to a 3-phase motor, and you wanted some lights to kick on at the same time the motor came on, then you could hook your lighting up through here. It's kind of a weird deal, but it's pretty cool stuff. So if you got any questions, please shoot me an email or post down below. I'll be happy to make some more videos for you. Hope you guys are enjoying your Memorial Day weekend 2011, and I'll talk to you later.